Welcome. Glad you're here. My name is Corrie Miller. I work for the Lake Champlain Basin Program as the Aquatic Organism Passage Restoration Specialist. I'm here with 3 colleagues that have worked diligently over the last year to make this happen today. And I just want to say that we've had our heads in the clouds, kind of dreaming this up and envisioning what we wanted for this day. And we've had our hands in like the nitty-gritty details to make this happen. So we're really excited to be here and have this come to fruition. And I'm really appreciative of these 3 folks' dedication, their sense of humor, their insight in this whole process. So I just want to say Karina Daly from the Vermont Natural Resources Council is right here. And Julie Butler from the U.S. Fish and Wildlife Service is right here. And Lynn Munno from Watersheds United Vermont is right there. So thank you. So partners across Vermont and New York have echoed the need for greater capacity in the region to advance projects that remove barriers for aquatic connectivity and to reconnect waterways, so like dam removals and culvert replacements. The capacity needs that we've heard about are in terms of both just the simply needing more people to do the work, but also in terms of people really wanting to build their skill sets and learn more about the sort of these projects that tend to be niche projects and require slightly different skills. So when we were envisioning this day, we envisioned it as one where those of you who are doing this work and people who want to be doing this work can gather together across the sectors and share with each other and learn from each other. So we really designed it with that in mind, which is why you see, I don't know, like 30 presenters, not quite, but almost. And we all come to this work from different places with different very varied experiences, different constraints on what we can do in the time that we have, and different motivations. And then really ultimately, many of us land on a project together and we need to make it happen. And that's sort of the fun of it, right? These projects can be pretty complicated. They have multiple phases. They have countless funding sources, some of which really don't always fund all of the things it needs to fund. When you add it all together, they have multiple partners, like I said, with really different constraints in the background and interests. I guess I don't need to go on with all of the challenges, but the projects are hardly ever straightforward, and they never go off without a hitch, but they're also like super compelling, and they blend art and science and chaos and collaboration. And I think there's a chuckle because folks know what that means, and you've been there and you've done that a little bit. But so they're certainly not boring, and they require so many partners to do all the different things and the skills that those different partners have. And these projects really matter. And I think that's why many of us are here today, because they matter for healthy ecosystems, for cold and clean water. They matter for communities and jobs in those communities, and for flood resilience, and many more things. And so it's really good to be here and share all of those interests with each other. So thank you for working on these sort of challenging and compelling projects, and for being here to learn and share that together. Our hope is that you are able to sort of learn a little something, see things from a new perspective, and have a little tiny spark of inspiration to take back to your work. And there are tons of people here, all of you. There's a lot of expertise in Vermont and New York and others farther afield who are working to do this work. And we're so thrilled that you're all here. And like, we had over 100 people sign up, and the interest is there, and it's really exciting. So thank you for coming together to share across the sectors. And to start us off, I'm going to be really brief here, but I want to introduce Laura Wildman. She comes to us from Save the Sound in Connecticut. And I'm not going to dive into all of her bio. It is printed. It also was emailed out to you. You can read it all. It's quite extensive and fun. She brings a vast and a deep experience to ecological restoration work, specifically dam removal projects, and her work has been all over the world. And so I'm really excited that she's here to share with us. And we were thinking back on this last night when Lynn, Karina, and Julie and I had a call with her. we kept hearing all of her ideas and kept getting excited and saying, yeah, that. So if it's a bit of a hodgepodge, you can blame the four of us because we really had a hard time reining it in. And she's got so much to share. So welcome, Laura. We're pleased to have you. And I'm going to turn it over to you.
Thank you. Okay, is the mic working? Yeah. Okay, great, excellent. And where is the remote? Let's get to that. Oh, I have to get to my talk too? Okay, how do I do that? I don't know how to use Apple's.
I'm sorry.
Max. Thank you. Go to the second one. Excellent. Excellent. Okay, I think I'll get down here because we got two screens and up there is too far away. So again, Laura Wildman. I've worked on over 100 or so dam removal projects, 200 or so dam removal projects. Most of my work has been in the United States, but I also work a lot in Europe right now, passing out grant funding for dam removal projects all over Europe. So that's fun too. I get to see just all the differences in each country I go into. I've done culvert right-sizing projects too. I do living shoreline projects and things like this and green infrastructure, all part of protecting Long Island Sound right now. So this is actually one of our dam removal projects a few years after removal here. And I think that starts with a little flyover. This is some of the herring below one of our other projects in Connecticut. And then we've got, let's just start in. So historic issues. I'm gonna start like it is. It's definitely a hodgepodge because they just kept on throwing in things they wanted. And I'm like, okay, it's only a 30-minute talk. Really? I'm not quite sure. It can be all that and more. So they're short little things. I'm gonna start from a talk that I give on kind of the historic process, the building of the dam removal movement in the United States. And this has been helpful, especially in work in Europe, because we're looking to recreate some of this globally as well as we move forward. But if we start with talking about dams, and I'm going to talk about other kind of barriers too, but as we start talking about dams, we've basically been building dams since the beginning of human civilization. I think it's like we're hardwired. I mean, how many of you have gone out in the river when you were a little kid and built like a dam across the river? Right? Come on, you can't just, yeah, it's a bunch of us, right? I've done it too. We all did that as kids. And so way back when, this code here, probably a few of you have heard of it, is actually one of the original dam safety codes. So it was chiseled in stone. This is what they were using to put their dam safety codes on. And I love it because it basically says if you're too lazy to take care of your dam, we're gonna sell you. If your dam breaks, you're gonna be sold for money. At least that's how I'm reading it. Like you're gonna be sold for money to make up for the damages here. Now that would be a really good threat. Our dam safeties are not that strong and enforcement is a little light, but that would be a really good way to get people to take care of their dams. Okay, but we've also been removing dams almost as long as we've been building them. Now it's harder to find the records, but we see this dam here way back 2900 BC that it looks like it breached at some point, probably soon after it was built. So we do see examples of dams that either failed or removed. I found another record of in 331 BC, when Alexander the Great led his forces through an area, and they had boats, so they had to remove the dams to get their forces through the Valley of the Tigris. Let's see. And then even just going into the history books in my own town, I was surprised to see, I knew there had been a lot of dams in our town that were no longer there. And I assumed, of course, most of them just blew out on their own. But what I found was an actual picture of them blowing up a dam in 1901. So we might be working more on proactive dam removal now, but actually we have been removing this type of infrastructure almost as long as we've been building this infrastructure. And there's a lot of other types of infrastructure that is causing disconnecting of our water systems that we have been building since forever. This is an example of levees, 5,000-year-old levees uncovered. We've got old irrigation systems, roads, culverts, coastal tidal defenses. We have been doing this for a very, very long time. We have been fragmenting our systems for a very long time. And my own family history, as any of you have seen me give a talk before, kind of follows this same process. My great-grandfather was actually on the first survey crew for the Roosevelt Dam and was an avid fisherman. And then my grandfather built dams on those same rivers, annihilated all the native species, but did provide water to Phoenix and what's the town right next to it that has all the golf courses? Scottsdale. That's it, Scottsdale. So basically dammed the living heck out of the Salton Verde rivers. And then, of course, I'm known for removing dams. So I think we were trying to keep the job security in the family here. But so now if we talk about the summary of kind of the proactive, so we have been removing dams for as long as we've been putting them in. But when we talk about the proactive dam removal movement, that's what I'm going to talk about here. And basically this kind of started with crazy talk, with crazy people I probably would have really liked, like Henry David Thoreau, who back in 1839, I love this whole quote, but I'm going to read just the end of it here. Mere shad, armed only with innocence and a just cause, I, for one, am with thee. And who knows what may avail a crowbar against the Billerica Dam. Now, I love that. So he was talking about this in 1839 as he went along this river on a boat with his brother. And then in 1861, he was actually the surveyor in a court case that was trying to remove the dams. So he was supporting the folks, the farmers that were trying to remove the dams. And then there's been other crazy talk when they drew John Muir's quote on the O'Shaughnessy Dam. If any of you read The Monkey Wrench Gang, is also a little nutty, right? But, you know, talking about basically removing this kind of infrastructure. But as crazy as that talk was, it made economic sense. We had aging infrastructure. We did need to remove some of these structures. So from a safety and economic point of view, it made sense. And it went kind of from crazy talk to being now a common tool in the dam safety, you know, toolkits at a state level. So we go from crazy talk, and then we have some big ideas. We have folks like the tribes out in the West. Oh, actually, wait, before, I've jumped a step. I wasn't even reading my own steps. Here's the next step is really the laying the ground for this through environmental regulation. So we had a series of environmental regulation from the 30s to the 80s that laid the groundwork for balancing environment with things like energy. And that made a big difference on how we look at these structures. So everything from the Fish and Wildlife Coordination Act, the Clean Water Act, Endangered Species, and then these which were more power-oriented, the Electric Consumer Protection Act and Federal Power Act, Section 10, these made a big difference and also required things like fishways to be put on dams, laying the groundwork for it maybe not making economic sense sometimes to keep certain dams. Then, after that, this is when we start having the big dreams. So around the 1980s, you get really big ideas. You get the tribes that gain federal recognition out in the West calling for the removal of the two big dams on the Elwha. But these were going to take decades to do. So even though they're pushing for this huge, audacious goal, it wasn't going to happen quickly. So what we did see is a lot of success in small dam removal and small barrier removal across the country. So we saw dams coming out, certain states leading the way. There was a 1990 paper when I first started removing dams in the 1990s. This was one of the few papers I could find on dam removal. And it looked at proactive dam removal in Washington, Oregon, Idaho, and California. And let me know that at least it was being done. And it was written written as an argument to start laying the groundwork for the Elwha Dam, because they wanted to show that dam removals had been done and that this was something that we could do. And then we start seeing Wisconsin and Pennsylvania really taking over with dam removals, started getting a lot of dams out in those states. And that was primarily through programmatic development at a state level. The state of Wisconsin really had a strong dam safety that felt this was an obvious tool for dams that no longer made sense. They actually made a rule that if the dam was not being used and there was not an owner, they were going to take it out. They would have a public meeting. They would ask if anyone wanted to step up to the plate who was financially capable. And if they did not step up, if there wasn't someone capable of taking care of the dam, they would go and remove it themselves. So that was a big step. And then Pennsylvania ended up having a big funding source that really helped them take out a lot to try to restore shad in that area. Pennsylvania also did a cool thing. They required posting of low head dams as liabilities and safety hazards, because low head dams are pretty famous, as you guys know, for rollers, hydraulic rollers that get people sucked in. They see this little dam, they think it's no problem, but actually those kind of dams really create this hydraulic scenario that lures people in and they end up drowning. So we started seeing a lot of success in Pennsylvania taking out low head dams. And then we've seen continued success after that through changes in policy and publications, often done by advocacy organizations and government agencies. And then we start finally seeing now in the more modern years, in the last 10 or so years, we start seeing those big dreams of the 1980s, these big ideas for restoration actually coming to fruition. So it kind of kicked off with the Edwards Dam being done in 1998, and we've seen an amazing restoration of fish post the removal of the Edwards Dam. And then we see right around the same time, we see the 2 dams on the Elwha River and 2 dams on the Penobscot River being removed too, to really dramatic success. The restoration efforts on these rivers are really amazing. So let's talk about our other big, huge fragmentation problem, culverts. Not quite as sexy as dams, but there are a lot of them. This is our problem. There are so many culverts, and we can see this when we look at a road map. I mean, this isn't even all the roads in the United States, and we compare that to a river map. If we go back and forth on that, let's see. I mean, that's a recipe for a problem here. So we have really fragmented our river systems through culverts, obviously. And when I say fragment, I don't just mean what we normally talk about, longitudinal connectivity, but I'm also talking about lateral connectivity, and a lot of us think about that. So not just up and down the river, but out into the floodplain too. All of these things play critical ecological roles for a successful, healthy river system. And not just longitudinal and lateral connectivity, we're also talking about vertical connectivity. So the connectivity of the river to the hyperrheic zone and the groundwater table, also absolutely critically important for all the species that are using these systems. And just here's, I thought, a great diagram, a really good, this woman here just did a few really nice diagrams showing this connectivity and showing how important it is, all the different trophic stages of use of these systems that we are looking at. So when we're talking about aquatic connectivity, we're not just talking about taking out a dam and fish getting upstream. We are talking about this kind of connectivity on a much larger level here. And I'll just show all the different ways we've done this, and I bet you guys could even throw out more. Longitudinal barriers. Well, we know obviously dams are an obvious one, but also we have weirs and tide gates that become issues with aquatic connectivity. We have culverts and bridge aprons. Sometimes even if we've bridged it, we put an apron in that is not passable. We have lateral barriers that include things like levees along a river system, embankments, this railroad embankment. Roy Schiff, who's in the audience, did a great paper talking about railroad embankment and its issues with connecting a river and nutrients. Flood walls and development. And then when we talk about vertical connectivity, we talk about things like concrete liners disconnecting them, and pipes and conduits, again, not allowing a river to interconnect with the groundwater system. And by the way, if you didn't notice, I took the base graphic from something in Australia. That's why we have a few kangaroos. So I thought about taking them out, but I was like, it's kind of cute having some kangaroos out there, you know? So I left them in. Now, I know most of this audience knows already the impacts of dams, so we'll talk about this. When we talk about the impacts of dams, remember, the reverse flip of this is all of these impacts are also what we're restoring when we're taking out barriers as well. So you have a dam in place, you get stratification of the water column upstream. You get changes in the temperature regime, you get increased evaporation and methane gas releases. That changes downstream, so you get changes in the temperature regime downstream as well from these changes upstream. You get water quality impacts within the impoundment that again are translated downstream to additional issues. You start getting things like harmful algae blooms, you get nutrient-starved conditions downstream, you can alter the flow regime downstream. You block natural building blocks like debris that's coming down that would have been a building block for downstream. And of course, you're blocking not just water, but sediment as well. And that becomes a big issue because a river is at balance when it is transporting both water and sediment. So you significantly disrupt downstream when you're blocking sediment behind a dam. And of course, you're blocking fish. But a lot of times people think that's the only reason we're doing that, and it's really not. They're so complex of the different layers we're looking at it. Here's one of the dams I'm working on right now to try to remove. This is the Rainbow Dam on the Farmington River. We are trying to get the owner on board, which has been a challenge because it's a big industry that's currently using the dam. But this is what happens to this impoundment. We've got significant harmful algae blooms, and that is a summer camp, a kid's summer camp, where they can't go anywhere near the water. In addition, you know, I have always thought of this kind of in the back of my head. I knew that the methane gas release was something, but it wasn't until I was on this site, a dam we are removing on the Naugatuck. Did you see his shocked face? The reason why his face is shocked is we just did a sediment probe, and we pulled up the sediment probe, and this happens. I felt like the Beverly Hillbillies, if any of you remember when he struck oil when he was out shooting, and this happened. And at first, the reason he had a shocked face, because we were like, did we just hit a gas line? Is there a gas line under here? And we're like calling people, is there a gas line under here? I mean, we didn't see a gas line. No, I don't think there's a gas line. And then I'm like, okay, before we completely freak out, because there also have these little bubbles all around it too. And we started probing other places in the impoundment, and sure enough, all of the spots came up with this massive amount of methane gas underneath. We did not light a match. I wonder if we could remove this dam just by probing a bit and then lighting a match. Because it was crazy. But certain dams, not all dams, but certain dams really have a methane gas release issue. And that becomes an issue, especially when people are arguing for green hydro type thing. You're like, really? Well, actually, you've got some impacts there too. This is another graph I like just because it really shows, again, the complexity of the situation. While we're talking about the effects of the barrier on water quality, hydrology, and sediment load, that affects the river morphology and primary production, which affects invertebrates, fish, and birds and mammals, all terrestrial species that are using these. So it's really the larger system we are looking at. And now, because of this is the hodgepodge thing. Well, also, no, put misconceptions in too. I'm like, oh, this is a separate talk, but okay. So we're going to go through some misconceptions that I think probably you guys all run into, and I have for sure run into globally, by the way. I want you to know that these misconceptions are global misconceptions. The first one, common misconception when you're trying to remove a dam, is that it's a waterfall. Well, you can understand the misconception. I mean, look at those two things. You know, they look pretty similar. The difference is, one is a natural feature and basically a very slow geologic head cut, so it's not completely staying in that position. But the other is a man-made structure. Man or woman-made, but probably most of them are made by men. Sorry, it's a timing thing. And really requires a lot of maintenance in order to stay being a dam. And that gets to the next misconception. Lay people think that all dams are maintained and that they're maintained under the current flow conditions. Like they're safe under current flow conditions, even though, as we know statistically, our flows are changing here. So that's a misconception because we know that that's not the case. Many dams are not currently maintained, and they're not up to date with current flows. So that's an issue. They also think they'd be told if they live in a dam breach inundation zone. Of course I'll be told. Nope, guess what? No federal law, not even any state law, although some states or municipalities choose to do this, but most don't. So primarily, if you live in a dam breach inundation zone, you're not going to be told this unless you know to look for it. And then they think that, hey, the dam's lasted this long, it'll be fine. I keep on saying, well, you know, it's the older ones that go. You know, the older it is, that's not an argument for why it's not going to go. That'd be like saying, I've been around this long, I'm going to be around forever. Well, guess what? I'm getting near the top end now, and I'm going to start going downhill. You know, that's what these dams are doing. So, and here is probably the most common misconception that I'm sure all of you battle, and I battle, and I'm definitely battling this globally right now because a lot of people in Spain are telling us that the huge floods that just happened are from dam removals, which, by the way, didn't happen in their area. They were going off a map that we had that listed the dams in their area, not the dam removals in their area. So, inaccurate information. And I understand this because when I first started removing dams in the 1990s, my mom was like, you can't remove dams, they're flood control. My doctor, you can't remove dams, they're flood control. I'm like, okay, no, not true, but okay, let's start there. So here's the difference. If you look at these two dams, I'm just curious what you guys think. The top one there, who thinks that would provide flood control, that top dam? Okay, and what about the bottom one? Who thinks that provides flood control? Okay, so the top one is a flood control dam. It definitely provides flood control. And here's the big giveaway. It's empty. See upstream? It's empty. It's empty up here. That's flood control. It has to be empty or partially empty to provide flood control. When it is full, no flood control. So when you're trying to explain this to folks, here's one of the best analogies I have. So you have a drip under your sink, right? In the kitchen, that's where my drip is. When you go to take care of the drip, would you put a bucket that's completely full of water under the drip? Would you take a bucket completely full of water, put it under a drip and go, okay, I've taken care of that. I just put a flood control bucket in there. No, you wouldn't. You would put an empty bucket. And you would also know that when that empty bucket filled up, it was no longer gathering the drip anymore, right? So that's the same as with flood control dams. And I'll explain that just slightly more technical now, although also using the buckets because I really like the buckets. A flood control dam is like a bucket with a little hole in the bottom, an empty bucket with a little hole in the bottom, or partially empty bucket. And that's how it attenuates floods. By filling up, letting a measured amount out, but having room to fill up. That's its flood control. When it's totally full, then it's not a flood control dam anymore, at least it's not acting. So below that little hole is what we call dead storage. That's not helping you at all. But you have live storage above that, and that's what you're filling up during a flood. Now, a small dam that's totally full of water is the full bucket. it's old dead storage. It's not serving, this little pointer stopped working. But anyway, you see the thing. The dead storage is completely up to the crest of the dam. That means it's not helping us with flood control whatsoever. And in addition, dams increase flooding upstream, no matter what dam they are, they'll increase flooding upstream. And if they're not maintained and they breach, they're going to have a catastrophic flow of water for people right in the middle of a storm, typically. Or you might have a flood control dam that fills up and they start opening the gates to release more flow downstream. And then again, people downstream were like, wait, we had a flood control dam. Yeah, well, now it's full and now they have to release more and now it's not really a flood control dam anymore. And dams, especially small dams, can fill with debris back behind the dam, effectively raising the head, the water surface elevation, even higher, so creating even more flooding upstream. I like this video. This shows, that's a full dam, no flood control, and did that stop that flood wall at all? No, it didn't stop it at all. The speed didn't change, the volume didn't change. All of that flood water that was coming down in that scenario just completely, and if we go back a second, I think the people standing near it also thought somehow the dam was going to stop that. Now watch, they changed their minds pretty quick. Oh, it's not going to stop anything. Oh, okay, we better move. Okay, we're out of here. So it's full. It has nothing to stop or slow down in this case. So that's one of the most common misconceptions. Also, with dam removals, some of them create large wetland systems behind the dams post-removal, and that actually does have the ability to attenuate floods. In this case, we only removed a portion of this very over-wide earthen dam, and this whole area ended up having the ability to attenuate floods. And that's that same structure upstream about a year after dam removal. And there's the dam. There's the dam. We took a breach out here because it was massively over wide compared to the river. And then now this system here does have some flood attenuation capabilities. Not all of our run-of-the-river dams we can do that too, but that was different. Another common misconception is removing the dam is going to dry up the river. It's going to go away. First time that was said to me in a public meeting, I actually laughed out loud. And that's a very bad thing to do in a public meeting when someone is being very serious to you. And then later, many years later, when it was repeated in almost every single public meeting I've ever been to, I started realizing what happens. If you're a layperson completely unfamiliar with the hydrologic cycle, and you come up to a dam that has a pond of water behind it, and you see water coming out of the dam, you think, that pond and that dam are the source of this river. That's the source. I just found the source. Which isn't the case, of course. There's normally a river coming into that whole system too, and there's groundwater and everything else. But therefore, you think if you take away that dam and that pond, there's not going to be a river at all anymore, okay? So again, erase the hydrologic cycle from your minds, try to think like that, and be like, okay, yeah, then I could see why someone would think that. But of course, it's not the case. And they think it's going to be just a mud flat and everything's going to disappear. This is that same site a year later. It still has the river. It was always a small river that goes through this. It's the same one we showed earlier. Another misconception is thinking that fishways are a happy medium. They're a fix, a win-win. It's a win-win. We can keep the dam and we can restore the river. Well, fishways, unfortunately, only restore a fraction of fish passage, typically. So only a portion of the fish, only certain species are going to get through. They don't restore any of those other things that we showed on the impacts map, like sediment transport or nutrient transport or debris. So they are a very, very partial fix. And it's a misconception to think either a traditional or a nature-like fishway is going to somehow be a win-win solution. It's not. It's a partial fix when you cannot remove the dam at all, but you're not really restoring the system. Basically, I compare it to this. You think you're getting this, like this bridge is over the Rhine River, and you think, okay, this walking bridge, it passes all of us. We got bikes, we got strollers, we got old people, everyone's going across the bridge and they're really happy. And that's what we think we're gonna get for passage on a fishway, but we're really getting something more like this. Like you're probably gonna lose the old ones and the young ones. A few hardy souls who are stupid enough to try might get across. So that's a little closer to what we're looking at with most fishways. Another common misconception is that rivers only move water. They just move water and sediment is bad and it's a pollutant, but it's not. A balanced river system has to move water and sediment. And if you take it out of the equation, you're going to create all sorts of problems downstream. You're going to disconnect floodplains, you're going to entrench systems, you're going to create all sorts of problems. It is a balance. We want to see sediment in systems. We want to restore sediment. We want to release sediment when we're taking out dams, as long as it's pretty much clean or at least similar to background levels. We don't want to think of sediment as this horrible thing in a river system. And the final misconception before I get onto the next hodgepodge subject is going to be that dam removal should be simple. I don't know where my red X went. Oh, I lost it. Okay. So there was a red X there. It's gone somehow. There's the dam, and I just had a red X. It's simple, right? I mean, how can Laura do this for a living? I mean, you make a plan, you put a big red X on the dam, you walk away, right? Come on, this is easy. Well, any of you that have worked on dam removal know that that's not the case. It's not as easy as that. You can't necessarily do it by yourself. We're working to remove this dam right now. At its low end, it's going to be a $30 to $60 million dam removal. At its high end, it could be a $300 million dam removal, all dependent on the sediment. It's an industrial system, so it does have some contaminated sediment behind it. I can walk that entire impoundment up to my knees. That's how full of sediment it is. It's got a railroad on one side, it's got a highway on the another, it's got a canal feeding an entire other dam and another powerhouse around the corner. It's got so many different issues. The complexities of this project just are a little overwhelming at times, but definitely keep us challenged. So we don't do this alone. We do this with a lot of people and with a lot of different steps. And this is just a few of the folks that I work with here. But I'm going to go through these steps and just kind of talk about the type of people that help us get this done. So the first phase of this is planning and feasibility. And I don't know why the Y is all by itself there, just on the next line, but that's interesting. So planning and feasibility, we're selecting a project. We're finding out if the dam owner is even interested in removal. Who's the person holding up the little papers? Am I fine right now? Okay. Okay, good. I'm good. So, and we're collecting all the available data that we can. And even for this phase, we have a lot of people involved all over the place. Obviously we have project managers, but we have advocates and other environmental NGO partners that are moving to get this done. This gentleman here, I could give you a story about every single person in all these pictures, but we would have to have a lot longer talk for this. But I'm going to point out Kevin right off the bat. Kevin paints houses for a living and ran into me in the 1990s removing a dam on a river and got so excited by it, he started his own NGO and has for the last 20 years been running a river brigade taking trash out of the river. And he alone is the one that targeted that huge multi-million-dollar dam that all of us thought, no way can we remove this because it was active hydropower. But he took video footage for 20 years below that dam and got all the mayors in the area excited enough about the vision of removing this dam that he has made that project happen just by sheer will. He still paints houses, by the way, and he does this on the side. So pretty amazing person, but it takes people with this kind of energy and excitement. She basically started dam removal in Lithuania. Pow's been doing stuff all over Europe. And then we have dam owners. This is our state dam safety, head of dam safety, and they own dams. So we have the owners. We have folks like Josh who are finding the money so we can get these projects done. We have Jessica here, who is an amazing environmental lawyer and is helping getting that project that Kevin started over the finish line. We have planners here. We have politicians. That's Bruce Babbitt, obviously did a lot for the cause back when. Then we have this stage where we're going field investigation, we're gathering the data, sediment is a big side of this, we're doing that, we're consulting with the regulators, and we have a whole lot of additional people. We have all those administrative people that help us out on things and financial things and regulators and funders, but then we also have a slew of scientists, all different types of scientists. We have fluvial geomorphologists, ecologists, folks like Josh here are specialized in assessing ecological risk, fisheries biologists, that's my husband on the far end here, but we all get involved in this, so a really diverse group of people involved. The next stage of the project, oops, I went quick there. How do I go back? There. Oh, farther back. Okay, so now we're talking about kind of what we think of as the engineering side of things. We're still doing surveys and delineating regulatory resources, but we're doing our hydrologic and hydraulic models. We're doing our engineering plans, construction cost estimates, and our specifications, and our stakeholder meetings, and we're interacting with the regulators the whole time to try to figure this out. And we've got, oh, did we lose the people in that one because of that? I think we did. Hold on. We got, there we are. And then on that, we've got engineers, landscape architects, modelers, cost estimators. This guy is a contractor, Michael, and when I'm doing big dam removal projects, he works with me right at the beginning to do some estimates of what we think things are going to be, because I like to have the contractor who would do the work or has done that kind of work before helping out. We have experts in regulatory process that get our applications all ready, and then the regulators themselves. Again. And then we have the construction and demolition phase of things, which is typically overseen also by the design team. And for that, we have also, in addition to the obvious engineers and the contractors, we also have a lawyer who specializes in contracts and insurance that helps me out. Scott helps me out all the time. Here's one of my favorite contractors, Dale. We have all these folks working on communication, writing, and outreach to get people in the community comfortable and integrated into the process. And then we have the adaptive management and monitoring phase. Clearly, the scientists are coming back in here, but also our educators, because when we leave a site, we also want to create these stewards of the future. We want to leave people inspired so that when I'm dead and buried, which isn't too far off now, these guys are then working on these things. Okay. So if we look at this whole system, there's only two other things I'm going to share with you before I go, and I think a lot of this is going to be integrated in all the great talks you're going to hear. But the first is, in that whole process that I consider really critical, is developing a vision. And the second one we'll talk about quick is the less is more approach to engineering. Again, I give whole talks on these things, so these are just short versions. Here's a dam out in Michigan I worked on. As you can see, and there's an apartment that has a view of this, they've got a quote-unquote waterfall. It's not a waterfall, but whatever. It looks like a waterfall. It's got this cool sign on it, kind of cool ruins, beautiful graffiti on the other side. So you can understand where removing this just feels like a loss to them. But then you work with some really creative landscape architects who have an entire idea for the park and the building and that cool iconic sign. And they talk about putting maybe a restaurant or a community center right there, and then building up the park with lots of access to the river. So basically trying to create this vision, because if all you can see at the beginning is loss, what you're going to lose, it's very hard for you to get on board with what this project might end up becoming. So this is one traditional way of doing it, having landscape architects draw things out like this. Now here's one you all can do, okay? This is pretty damn cool. I just learned this about a month ago. I have been doing photo renderings for years. It takes a while, and I charge a decent amount to do them, okay? Because I go out and I do field work, I gather all my photos, but I did these in like 5 minutes. I'm going to show you why. First of all, those aren't even the real original photos. I photo rendered the lake on, because what I had was pictures of the impoundment dewatered. So these are properties along a dam we're trying to remove, the Rainbow Dam again, and I went to the front of the properties in a dewatered condition and got kind of what their view is like. And what their view is like when we dewatered it, because we were dewatering it for a repair, is like this. And they're like, what do you mean? You know, I had this, and now you want to do this? And now I want to kind of show them what a vision's going to be. So this is so easy. If you have Adobe Photoshop or can get a copy of Adobe Photoshop, it takes 5 seconds. Matter of fact, I made those lake ones last night after dinner because I thought I didn't have a picture with it. So you go into Adobe Photoshop, you take that little polygon selector, you select, in this case, I selected these whole areas that are dewatered, just the dewatered. I left the river there, but I selected all the dirt, right? And then you write something like, put in a meadow. Oh goodness, that got really loud. Put in a meadow with a trail and some wildflowers. And it gave me that. That's nutty. It gave me 3 different choices, and every once in a while there was something weird in it, but you can always edit out the weird things, like take out the person's head floating in the water. You know, you can edit those things out. But even with words, you can edit it out. You don't have to actually edit it out. Just say take out the head, and then, you know, the head's gone. So this took minutes. And you can play around with it. Say, no, I want a staircase going down, or I want a picnic table, or what. This is a pretty good idea. Now, I would argue you have to have some concept of what it really is going to look like, the site is going to look like, because you could get nutty here, you know? So you have to have some idea of what it really is going to look like. You probably should have done some sediment probes already, know what's impounded sediment, what's not. But you can go out and do this kind of thing. In addition, you have creative people creating visions for folks that integrate like historic issues. So this is an actual site that my last company worked on that had a lot of historic, and what they did is they left part of the dam in, created a trough on the top, and pumped water up. So it still looks like a dam, but it's not a dam. So how weird is that? But it has all this historic stuff, so now they're all happy. I think it's a good example. It's a partial removal. And now just on ending point relating to less is more, I know I'm an engineer, but I strongly believe that we need to do less when it comes to rivers. We can only predict them so far. And if we're overly predictive, we will get it wrong. And I'm going to give you good case examples of that real quick. This is the one I've shown you already before. We did nothing. We took this piece of the dam out. Here's what the impoundment looked like before. And then it looked like a mudflat for a second, but it went right back into its original channel. And we did nothing. And I came back a year later and took that picture. A year later. We didn't do anything. We didn't do plantings. We didn't do anything. That's a year later, just totally on its own. That one's in New Hampshire. You do have to make sure you have to, for understanding which projects are less is more, I give a whole talk on this, but you do have to understand the river profile, you have to understand things relating to the sediment, and you do have to understand infrastructure issues, because these are critical when you're making this decision. Now let's do the other example. This is another project I was involved in California, San Clemente Dam, and we did discuss ahead of time just taking stuff out, breaching through this, leaving all this sediment in place, breaching through here, and not doing anything here, just letting it go through. But it was decided, the engineers decided later not to do that. So, oh, no, wrong direction. Sorry, I'm a little confused by this thing. So they went with, they breached through the ridgeline, and they really defined the channel there. They really defined the steps. They probably had all their Roskin curves out and other geomorphic principles and really created this. Well, the river had something else in mind. Here was the engineered approach. Here was 2 years later. So the river said, thanks for the supplies, but I'm going to use them in a different way. I'm going to move them around. So totally different, obviously. Still use the rock, so important to use natural materials. Here it is from a aerial view. You see the highly engineered channel, and then you see later after the river decided to redesign it. And here it is again, engineered, same once the river has come. And I'd say the river did a better job. It looks nice. I think the river did a really good job there. So we have to have more trust in these natural systems. This is another dam, just gonna go through it quick. It's an earthen dam, and what my firm did at the time, they took all the earth off the dam and just put it in the impoundment. Put it in the impoundment and spread it out, put trees, the trees came down and everything else that came off, and just spread it all out into the impoundment and then let the water go through. And in the end, this project came out really nice. Now, admittedly, again, you have to understand sediment quantities and what's gonna happen, but basically did not define a channel through this and just let the channel evolve through what was basically a wetland system. If we go to the finish on that, that was like after it's all looked like just chaos, and then it started vegetating. And, you know, this is with, again, just kind of spreading out the chaos and letting that complexity of system develop on its own. So that's it for now. Thanks for listening to me. Take care.